what connects a philosopher's quest for universal knowledge, a weaving machine, and the birth of modern computers. These unlikely pieces of history all played a part in the evolution of artificial intelligence. Stay tuned as we uncover the incredible journey from Enlightenment logic to programmable machines that change the world. Hello, I'm Majdi El Jazmawi from AI Virtus. As a computer engineer, I'm thrilled to guide you through today's video, where we'll delve into the captivating evolution of artificial intelligence. From the logical innovations of the Enlightenment to the revolutionary programmable machines of the Industrial Revolution, we'll explore how these pivotal moments transformed our understanding of machines and laid the groundwork for modern AI. The Enlightenment, the Age of Reason. The Enlightenment was a transformative era where logic, reason, and science redefined how we thought about the mind and intelligence. Leibniz's vision of universal knowledge. Gottfried Wilhelm Leibniz dreamed of a characteristica universalis, a universal symbolic language capable of encoding all human knowledge into mathematical symbols. His invention of the stepped reckoner, a mechanical calculator, demonstrated that machines could perform logical and arithmetic tasks. These ideas laid the groundwork for modern programming languages and algorithms. Newton's mathematical universe. Isaac Newton's work in Principia Mathematica showed the universe operates on logical and predictable mathematical laws. Enlightenment thinkers extended this mechanistic worldview to the human mind, seeing intelligence as something that could be explained by logical principles. Newton's influence encouraged the exploration of intelligence as a system of rules and computations. Boole's logical framework. George Boole expanded these ideas into Boolean algebra, which represented logical operations through binary values true or false. Boolean logic became the foundation of digital circuits, and later, the computational logic used in AI. The Enlightenment gave us the intellectual tools to think about intelligence in systematic, computable ways, forming the bedrock of AI. Philosophers who saw the mind as a machine. Philosophers of the Enlightenment and beyond began to conceptualize the human mind in ways that resonate with modern AI principles. David Hume's cause and effect reasoning. Hume compared the mind to a system of cause and effect, much like a machine responding to stimuli. Modern AI systems use similar principles to process inputs and generate outputs based on learned patterns. John Locke's blank slate. Locke's idea of the tabula rasa, that the mind starts as a blank slate and is shaped by experiences, mirrors how machine learning models are trained on data. These philosophers laid the intellectual groundwork for understanding intelligence as a process of learning and adaptation, crucial to AI development. If exploring the roots of AI has inspired you, be sure to like and subscribe to AI Virtues for more engaging content. I'd love to hear your perspective. Do you believe AI's development owes more to the philosophical insights of the Enlightenment or the engineering breakthroughs of the Industrial Revolution? Share your thoughts in the comments below. The Industrial Revolution, where philosophy meets engineering. The Industrial Revolution brought Enlightenment ideas to life, introducing machines that could automate tasks and follow instructions. The Jacquard Loom, programmability in action. Invented by Joseph Marie Jacquard in 1804, the loom used punched cards to control weaving patterns, allowing complex designs without manual intervention. Why it was revolutionary. It introduced the idea of programmable instructions. Punched cards later inspired the programming of early computers. The loom's programmability foreshadowed how modern AI systems follow coded instructions to achieve complex outcomes.
These cards are what carry the instructions that are read by the apparatus on the second floor that tells the loom what pattern to create. The holes in the cards are read by a series of pins up in the apparatus, and those holes tell the apparatus which threads down here should be raised for each pass of my shuttle across the warp. Some of you might recognize these cards as looking similar to computer punch cards. Back in the early days of computer technology, punch cards carried instructions that told the early computers what kind of calculations to do. So this loom is the great-great-great-grandfather of the computer technology that we all use today, and that technology started with a machine that produces cloth.
Steam engines and automation. Steam engines powered industries with unmatched efficiency, replacing manual labor with mechanized systems. James Watt's innovation of feedback loops allowed machines to self-regulate, introducing an early concept of autonomy in machines. Feedback systems are a precursor to AI algorithms that adjust and optimize based on input data. The Industrial Revolution transformed machines from tools into programmable systems, laying the foundation for intelligent automation. Charles Babbage's Analytical Engine. Charles Babbage's analytical engine was the first conceptual design of a programmable computer. What it was: a mechanical computer capable of performing any calculation, with features like memory for storing data, loops for repeating instructions, conditional branching for decision making. Although never built in his lifetime, the engine's design anticipated the architecture of modern computers. Why it was revolutionary? It showed that machines could be programmed to solve problems dynamically, not just follow static instructions. Babbage's analytical engine marked the transition from machines as mechanical tools to devices capable of computation and decision making. Ada Lovelace's vision of machine creativity. Ada Lovelace, often regarded as the first computer programmer, saw potential in the analytical engine far beyond its time. Her contributions. Ada Lovelace wrote the first algorithm designed to be executed by a machine. She recognized that the analytical engine could manipulate symbols, not just numbers. Her vision, Lovelace predicted that machines could create music, art, and more if given the right instructions. She argued that machines could extend into realms of creativity, an idea now realized in generative AI like ChatGPT and AI art tools. Lovelace's imagination bridged the mechanical and the creative, predicting a future where machines wouldn't just follow instructions, but contribute to human creativity.
Ada Lovelace was the world's first computer programmer. She wrote the world's first complex computer program in 1843. She also was an extraordinary mathematician. And as a young woman, she was introduced to the inventor Charles Babbage. And he was working on what would have become the world's first computer, the analytical engine. Now, the analytical engine wasn't built. They didn't get enough funding. But had it been built, it would have worked in 1843. And while Babbage was trying to automate mathematics, Ada Lovelace had the foresight to realize that these computers would be able to be the tool of human imagination. And she realized it was what we told the computer to do, the instructions we gave it, the programming, that would unlock this magic. So here it is, the world's first complex computer program. It has line by line instructions. It also has looping and conditional branching.
Bridging two eras. The Enlightenment and Industrial Revolution didn't just inspire one another, they laid the groundwork for the intelligent systems we see today. Enlightenment thinkers provided the logical frameworks to understand intelligence. Industrial engineers created machines that could implement these ideas through programmability. Together, these eras demonstrated that intelligence, logical, mechanical, or creative, could be replicated and enhanced by machines. Conclusion. From the Enlightenment's logical breakthroughs to the Industrial Revolution's programmable machines, we've seen how ideas and innovation laid the foundation for artificial intelligence. These eras weren't just about advancing technology, they were about redefining intelligence itself. Once again, I'm Mujdil Jazmawi from AI Virtus. If you enjoyed this exploration of AI's beginnings, don't forget to like, subscribe, and share. In our next video, we'll dive into the groundbreaking innovations of the 20th century that shaped modern AI. Until then, stay curious and enjoy uncovering the wonders of artificial intelligence.